joined Delphix, and he now leads the Perforce Delphix in Africa. Gary, if you go to his LinkedIn, is known for his passion for driving business value with cutting-edge technologies, and he brings both the global experience and the practical insights. So please join me, colleagues, in welcoming Gary in today's session, and from Perforce, which is our gold sponsor for South African Oracle User Group Conference. So Gary, you can go ahead, and just colleagues, to make you aware, this presentation will be recorded. So please give us a heads up if you're fine with that. But yeah, we would like to record it for reference as well. So you can take over, Gary. Thank you very much.
Excellent, Muzzy. Thanks for that great introduction. And yes, at the time I thought the software was complex, and that was back in the 80s, but it seems to have got even more complex these days. But you're right, I've done a lot of work, a lot of projects around the globe. At the moment, I'm working for Perforce Delphix. Delphix was an organization founded in 2008. We brought our first product to market in 2010. We introduced actually the masking solution in 2015 when I joined the company, and we've developed it since then. But anyway, let's talk about arming your cybersecurity warriors and protecting your data. So I'm going to follow on from the theme that I created last time, because the last time I presented, I just visited a military training establishment in the UK, and I saw this sign up there, and it was quite inspiring in some ways, but in other ways I found it a little bit amusing. I felt really for the people, the 80 people that were just targets. I thought that was rather rude. But as it describes here, 9 of the real fighters, and we are lucky to have them, but they make the battle, of course. But the one is a warrior, and he will bring the others back. And at first I thought, you know, here's a warrior that's destroying everything. But in actual fact, reading a little bit more about Heraclitus, he actually talks about the one who preserves, right? So the warrior is the one who preserves the men. Or in actual fact, in some articles, it talks about preserving the home. But the cybersecurity warrior, therefore, is the person that protects the home or protects the business, right? And that's the person that keeps your data safe. So now I'm going to talk about the cyber warrior. And obviously, you know, when we're implementing software, we try to make sure that it brings business value, and preferably strategic business value as well. And the sort of things that provide value are those that make your business go faster. Okay, so you can get to market ahead of the competition. Those pieces of software that make your business better. Okay, so that you can retain your business, retain or grow your market share. And of course, there's also strategic business value in making your business safer. And that's what the cybersecurity is all about. And if you look at the world today, it seems a much more dangerous place. Not only do we have inadvertently DBAs potentially breaking your data and accessing your data, but it seems like everyone out there wants your data, including some, you know, state actors that are really trying to cause disruption. So one of the big issues around businesses is really around accessing data. There's lots of data out there. It's growing all of the time. And one of the big problems that we have, or one of the first things that we need to do when we're masking data is of course to get hold of the data itself, right? So what we're looking to do is get hold of the data, then you've got to protect the data, and then you've got to distribute that data around. So one of the things that we first need to look at is how do we get hold of the data? And a lot of the problem around, you know, masking the data or obfuscating the data or pseudonymizing the data, tokenizing it, if you like, is we're trying to create fictitious data, but we need the data to be useful and accessible. One of the things that we talked about in the last SIG that I did was around the delivery of data. And one of the things that Delphix brings was its continuous data product. And that was all about how can we get data quickly to a place where we can manipulate the data, protect the data, and then share it with other people. And the thing that Delphix brought to market in 2010 was this idea of block sharing. Now, it's not a new idea. It's actually developed on the back of a file system called ZFS, which actually Oracle acquired Sun a few years ago, 2008, I think it was, or just before then. And it was Sun engineers that developed this block sharing technology that we use to actually deliver data very, very quickly. And if you recall, in my last section, I kind of built this picture up, which kind of shows that what block sharing does. Now Delphix does this block sharing. What it effectively does is provide file pointers to shared blocks of data. So instead of moving data around, instead of getting a mass copy of data and then copying all of that data and putting it on another server, what we actually do is we present an NFS or an iSCSI mount point on the database server, and we point to the shared blocks of data that reside on storage attached to the Delphix engine. So that picture at the top, rather than creating 102 terabytes worth of 6 copies of this 17 terabyte database, what you do with Delphix is store the 17 terabytes compressed in actual fact down to 5 terabytes inside of the Delphix engine, and then we just provision file pointers to those shared blocks of data. And the initial size of those virtual databases, as we call them, are very, very small. And that really allows you to give lots of copies of data. But it also allows you to do a little bit of time travel on that data as well. And if you take this and the context of a masking solution, so if you've got your production data and you want to create a copy and then you mask that copy, often you have multiple versions, multiple copies of the data. You might have a development copy, you might have a test copy, you might have a UAT copy and a pre-production copy maybe. But if you want to mask all of those, and you're masking billions of rows or hundreds of millions of rows potentially, then that process is going to take some time. And so what the advent of this block sharing technology can do is, you get a copy of the data available to you. That copy is on a small footprint. It has time machine-like capability. And one of the biggest issues around masking is actually changing the data, providing realistic data, and not breaking the application. And we'll go into that in a little bit more detail. But effectively, what the block sharing technology allows you to do is to try to mask something. And if the application breaks when you test it, then you can actually rewind very quickly, move back to the pointers, the original pointers, and then start again that process of masking, right? So it gives you a time machine capability, but it also allows you to clone from clones. So the idea being, when you are implementing this solution, is to get a virtual copy, ensure that that copy is masked. We can refresh that copy very quickly and then remask it. But your downstream systems, instead of masking those, you are just refreshing or restoring or cloning from the mask master. And in that way, rather than waiting, let's say if your masking job takes multiple hours, then you just mask once and then you clone that mask copy whenever you need it. And that process, rather than taking hours, just takes a few minutes. And that's the value of this block sharing technology, snap cloning, if you like, that ensures that you can mask the data and then give yourself a very quick copy of that data. And a recent example of this, I very recently, we were working on a very large insurance customer, and they had a 59, it's probably a bit more than 59 terabytes now, I'm sure. But they had a number of, the typical dev test QA copies of the database. They'd run out of storage on their Exadata, their non-production Exadata system. They were close to running out of storage on their production Exadata system as well. And what we're able to do there is bring that data into what we call continuous data engine. We compress that data down, not quite 50%, and that's mainly because this database was running TDE, transparent data encryption, so the compression is a little bit less. But what we're able to do is then provision a copy from that, what we call the D source, the data blocks sitting in the Delphix engine. And we could provision a copy in just 13 minutes. And we created a master copy that we ran a masking development exercise against. And once we'd masked that copy, then we're able to clone multiple, that dev, test, and QA copy. And in actual fact, those 5 copies, so there was one masked copy, well, 4 masked copies effectively, 1 masked copy and 3 clones of the masked copy. And then they also have another copy of the database that they use for production offload and production fixing, prediction testing, that sort of thing. So if you can see with this customer, and the database was huge, right? 60 terabytes and 100 schemas. So that's quite an interesting idea. And in the next slides, I'm going to describe, you know, this kind of things you need to think about when you want to mask your database, and it kind of emphasizes why those things might be important, particularly when you're dealing with very large data sets. So why mask your data at all? So one of the big issues that we've got are the laws that have recently, and regulations that have come into force. One of the original ones was GDPR, the General Data Protection Regulation, that was pan-European regulation that was brought into force. And that really specified that you really should only use personally identifiable information for the purposes that you've told your customer that you're going to use that data for. And that probably isn't around testing and development, right? So what you shouldn't really be using your production data, PII data in production, and that kind of breaks the GDPR laws. But not only that, you also risk that data being leaked. Okay, so if you can imagine you've got a 10 terabyte production database and you have, you know, 3, 4, 5, 6 copies of that, you have 6 times bigger surface area of risk. So there's 6 times more PII data available to access. But not only that, in your non-production environments, those environments tend to be accessed by potentially more people, right? And even third parties. So the requirement to mask data is quite high with the advent of GDPR, and also that obviously the POPI Act in South Africa as well kind of mimics that to some extent, so certainly overlaps it to a large extent. But it's a similar story, right? We shouldn't be using your customer data in non-production environments. But one of the other things that have made masking really an imperative is the advent of AI, right? Because previously for test data management, you know, you could argue, well, we can't be masked, we could just put production controls around it, and that will protect the data. And there's someone out there in your business probably with a risk waiver that says that they will take responsibility for that waiver, the fact that you've protected those non-production environments. That generally tends to slow down the development process. But actually now with AI, AI requires training data sets, you producing language models potentially from your own data. You know, if you're doing retrieval augmented AI, so you're actually asking your AI, your language model questions based upon your customer data. So you want to bring an answer back that's specific to a customer or a set or a type of a customer, then you're at much greater risk of leaking that data out. And so this advent of AI really puts an imperative on organizations to actually bite the bullet and start to mask that data. But the other thing also, a recent regulation in South Africa is the JS2, or Joint Standard 2, which is brought about by the financial sector regulator, or the Prudential Authority of the South African Reserve Bank. And that regulation really gives POPI a little bit more teeth, actually, and you know, companies can be liable for masking, but also for the resilience of their data, and part of that is data protection as well. And I've noticed that there's a significant uptake actually in South African businesses looking and acting upon getting data masked in non-production. So you might ask the question, well, why haven't they done it beforehand? Okay, and I say, well, I talk to people now and I said, why haven't you grasped the nettle? And by that I mean, you with a stinging nettle, it tends to sting you if you're gentle with it, right? If you rub against it with the back of your hand, but if you grasp the nettle and get the job done, then it tends not to hurt you quite so much. So really, businesses have tended not to grasp this nettle because it is a difficult challenge and it can potentially stop your developers doing their work. There's all sorts of issues and problems with masking data, not leastly that when you mask the data, you're probably going to break your application initially. And so those masking challenges are, the applications are large and complex. You've got very, very large data sets that take quite a long time to mask. Those databases are relying on referential integrity, so you're going to need to maintain that integrity. But on top of that, applications validate data for consistency. So if you've got a South African ID number, for instance, and a date of birth, and you've masked the date of birth, often inside of your application, you're checking that the SAID matches the date of birth. And obviously, if they're inconsistent, then your application is going to throw up errors. So actually, when you mask data, you have to consider composed fields that are composed of different values. And that's, even names, for instance, first name and last name in your database, you might be also holding full name. Now, if I mask a first name and then a last name, and then I see a full name and mask it, often that full name will be masked very differently from the composed field, the two separate first and last name fields. So that has to be handled. The other issue with masking is that the fact that these applications are interconnected across your enterprise. So you can't just mask one application because that's the easiest one and that's running on a database we can understand and we know what's going on there. If you mask that, you're going to break your integrity across end-to-end testing platform, right? So you have to really look at masking as holistic, and you've got to go across and get a minimum viable set of applications that you can mask so that you can get that end-to-end testing. And that's quite a difficult challenge, right? And that's actually where that virtualization solution comes in, where you can create copies of databases quickly and do that iterative rewind and testing. The other challenges are, data has relationships, it has time and date order. Also, data can be dirty, right? Everyone says, no, my application's clean. But at some point in time, as your application has developed, you've brought in different validation rules. And I encountered that recently with masking a very large oil company's data. What they said was initially they didn't have a regulation that checked ID numbers when they were uploaded to the system. So they could, for testing, they could upload any kind of identity number. But today they've got validation rules in place. And therefore, if you download the data and then try and upload it back up, you can't actually get that dirty data back into the system. So, and that's true of masking, right? You need to make sure if you're expecting certain values and you're going to mask them in a certain way and they don't conform to that, then there's an exercise really where you need to clean that data up before you mask it. But that's quite kind of interesting, right? Because not only will that help you get your masking done, but it will help you with automation. Because with the advent of AI is not going to understand if your data is incorrect. Okay, so that data cleansing exercise is probably something that you ought to be doing anyway. And then the other point is that data today is dispersed across the hybrid cloud and different enterprise data centers, and also locked in SaaS applications in strange and esoteric formats, right? So there's a much bigger challenge to get that masking done. But as I said, that JS2 regulation, the advent of AI means that you really need to start to do that masking. So how can we tame that masking complexity? How do we go in and either use a product or develop a masking capability that will help to ensure that you're protecting your data. The masking job process isn't complicated and long-winded and doesn't break all of the time and doesn't slow you down. So I've been, working with Delphix for 10 years now. I joined the company when we introduced our masking product, and I've seen many organizations go through this process of masking their databases. And here's some of the things that I've seen. Okay, so I hope you like the background pictures here. I've got different pictures with people wearing masks. I thought that might be quite pertinent, but anyway, the first thing is around inventory creation, right? So if you've got a big application, a large database, what you need to be able to do is to understand where the sensitive data is. Now, you could rely on the business, right? The business might say, I know exactly what data is sensitive. I understand the regulation. We need to conform to POPI, but also we need to protect our crown jewels and make sure that, our commercially sensitive information is protected as well. I know exactly where all of those fields are, because when I look at my application, I know what's sensitive. So that's interesting. And it's probably true that all of the columns or fields that they find are sensitive, but how do they know what's lurking inside of the database? Because the front end of the application, the business end, if you like, of the application, doesn't really show you necessarily all of the data that resides in a database and in a system, right? You may only be seeing a very small subset of what's out there. So it's quite important then that you look through your whole database and discover sensitive data. And one of the things that you need to be able to do is automate that inventory of sensitive data, because today's inventory is probably going to be different from tomorrow's inventory. And I discovered that recently. That 59 terabyte database that we masked with 100 schemas, the first time we masked it, great. The second time, things had changed. And the sort of things that had changed, they'd actually deleted tables, but also columns had changed. New columns had appeared, some columns had been removed. And so it's quite important that you can actually refresh that inventory. And one of the things that actually our tool brought in quite early on was the ability to refresh what we call a rule set and bring in the new columns, but also apply this sensitive data discovery process against the data. So in that way, when you're releasing new applications, you can be sure that then any new columns that appear can actually get this discovery, and we can check whether they're sensitive or not, and we can automatically assign an algorithm to them. So that inventory is important. It's important that you get a kind of an automated discovery, and probably important as well that's composable and reusable. Okay, and one of the nice things is once you've got that inventory, it's okay in an application, if you've built an application, to present that inventory, but it's also quite useful to export that in a format that anyone can use. You can report against it, let's say in a CSV file format, and people can look at it. And in the case of our solution, we also allow you to modify that. So if you want to do some bulk updates of fields that are sensitive or ones that aren't sensitive, particularly when you're talking about hundreds of columns or thousands of columns in hundreds of tables, then it's important you have a fast way of doing that. So not only are we able to export that, but also an API helps to automate the process of creating your masking rules and also running the masking as well. The other point as well is that, if you're going to build a masking solution, then you want to be sure that you can integrate that with other tooling in your organization, both including your lifecycle management tooling, your APM tooling, and potentially your business level data governance tooling. I've worked with a product called Calibra where the business is assigned the risk levels for different categories of data, and we've actually pulled that in to the masking solution to then apply algorithms based on that business level sensitivity. So automating inventory creation is the first point, and I've got 5 of these points, by the way. The second point is you need to be able to protect all of your data sources. There's no point saying, hey, I've got a great script that I can run against Oracle databases and maybe I can get it to work against SQL Server. Really, you need to be able to run these algorithms, these masking algorithms, the sensitive data discovery across all of the data sources that your your sensitive information resides in. So that's relational databases, NoSQL databases, SaaS applications. Now, the nice thing around some of the SaaS applications as well, now there's an API into those, but also they often provide a JDBC driver. Okay, so if you use CData or something like that, you can actually connect to these applications as if you're connecting to a database, and that's quite useful in both the discovery of the sensitive data and actually masking those data sets as well. You need to make sure that those JDBC drivers offer read and write capability. But if they do, then it's useful to be able to use those to do the masking as well. Obviously, the hybrid multi-cloud endpoint support. So, if you look, for instance, there's a lot of businesses these days doing analytics on the cloud native databases like Databricks and some of the others out there. And if you look at Azure, the Azure Data Factory or Azure Fabric as well, if you like, one of the things there is Synapse endpoints. There's very many endpoints that you can take data from and pass data to in kind of these workflows or ADF templates. And one of the things that we've done as well, we've got a SaaS solution that sits within Azure, which will allow you to mask any of those Synapse endpoints, connect to them and mask the data as it travels through the pipeline. But I think one of the most important things to connect to are file systems. Because even if you don't have a JDBC driver to connect to an esoteric kind of application, then as long as you can export that data into a file system, then if you can mask those file systems, and in our product itself, we support delimited files, XML files, JSON files, Parquet, vSAM files. And interestingly, there's a product called Temenos T24, and that has quite an interesting structure, right? That uses a blob column in a database, but within that, it has what we call a JBase format or an XML format. And what you need to ensure is that whatever tool you're using or whatever you're developing has the ability to look inside of that blob, that binary large object, and parse the XML or the JBase format, so you can discover the columns that are in that, the sensitive fields that are in that, and obviously mask them as well. So that's point 2. Make sure you can connect to all the data sources. The third point here is determinism, right? Consistency. So deterministic means I'm going to mask the same thing the same way every time I mask it and wherever I mask it. So I'm going to take a value, I'm going to replace it with a fictitious value, but whenever I replace a specific value, I'm going to replace it the same way every time I do that. And that is key to ensure that you have referential integrity. But there's multiple kinds of referential integrity. If I go into an Oracle database, there's a referential integrity within that database. So quite a while ago, I was masking an insurance application, and the policy ID number existed in 900 of the 3,000 tables. Now, I didn't have to mask all of those tables because obviously applications only use a certain number of those tables, and in a off-the-shelf application, not all of the tables are used. However, what I need to be able to do is discover that policy ID number, and if I am going to mask it, then I need to mask it the same way across that database. But then also that policy ID number might be reflected in multiple other systems, both databases and file systems and SaaS applications, and therefore I'm going to need to mask that value or modify that value in a way that's deterministic and is the same across all of those applications. Now, the problem with being deterministic potentially is the same problem you might get with not changing your password frequently, in that you can have kind of brute force attacks on that data. So another important feature around being deterministic is the ability to change the key or rotate the seed that is used to mask the data. So if I mask Gary to John 1 week, if I change or rotate that key, then Gary's going to be masked to a different value next week. And obviously, there's quite a big consideration if you are going to change your masking, because if you're doing end-to-end testing and you're masking multiple applications, you then need to synchronize the fact that you mask that application with an updated algorithm, and you need to coordinate that across all of the applications. One of the other key features as well is what I call algorithm federation. What does that mean? Well, your data resides in your enterprise across hybrid clouds, multiple locations, multiple data centers. If you're going to mask a very large database, let's say multi-terabyte database, then you really need your masking engine to be close to the data, so you're not suffering any network delays and lags in masking that data. And therefore, it's good to have a central location where you're creating the algorithm, the scripts, or whatever you do use to mask the data, but then that you can export that securely and run that algorithm in an engine that's running near to the data. And you know, our Delphix continuous compliance solution does exactly that. You can author the algorithms within one engine and distribute, export them in an encrypted form and distribute them to other engines where you've shared the similar key across all of those engines. And obviously, you need a very secure way to be able to do that. The other thing about masking, I've got here, I say one way and permanent. So a lot of people want to say that once we mask a value, we want that to be permanent, we want it to be irreversible, and we need it to be securely masked. Now, that's all well and good, and we do have algorithms that provide one-way permanent masking, like our secure lookup algorithm. But also, there are cases where you might want to have a reversible algorithm. That is, you want to change a value and provide a fictitious but format preserving value, and pass that information to a third party. But when you receive that data back, perhaps it's been enhanced by whatever that third party does, then you may want to re-identify the data so that you can use it again and understand who the data is ascribed to. And so with that secure reversibility, there's a bit of a responsibility there, in that you don't want anyone being able to reverse those algorithms. And so within our solution, we provide a protected area where you can actually create a re-identified job. But again, that's role-based access control on that, and attribute access control as well. So that's the third point: being deterministic, having some enterprise capabilities around federation and seed rotation and securely reversible algorithms. Point 4 is, being realistic. Okay, so I was working on a solution recently, and their masking really broke the data effectively. And that's one of the reasons why your developers and testers really, when they hear the words masking and protection and actually not production-like data, then they get really nervous, because they understand that, the richness of your application and the ability to test it is really down to the richness of the data that's in there and the edge cases of data. And if you destroy that richness, or destroy what I call the utility of that data, then they can't use it. It's pointless to test on data. So, a classic way is to give a fixed value for something and then increment a sequence. So rather than Gary Hallam, you're working on user 1 or user 1, 2, 3, 4, 5. And that really kind of breaks the integrity, and the utility of the data. So when you're performing your masking, you not only need to be deterministic, mask the same thing the same way every time you mask and wherever you mask, but you also need to try and preserve the format of the data and retain the data utility. So if you take, again, the South African ID number, that contains a date of birth, it contains a gender, and it contains a checksum, a LUN number. And so often if that LUN number is missing or the gender doesn't match the gender of the record that you've done your masking in, or the date of birth, then you break the utility of the data and it doesn't work. Okay. So that data needs to meet validation rules, right? And so it's really quite important that you have an intelligent solution that can look at the validation rules, or when you first mask the data, you can look at it and adhere to the validation rules. And preferably you want to try and do that without having to do any coding, right? You want a graphical interface that will help you to use certain techniques to maintain the utility of that data. The other piece in there is around relationships as well. There's no point in having a death date before the birth date, for instance, or a policy start date after the end date, or a contract signing date, that sort of thing. So it's quite important that your solution can take into consideration time order and make sure that the time order remains the same. The other one about relationships is often around addresses, right? The address must match the postcode, or you want to be in a certain specific region. And there are techniques and ways that you can maintain that. But it all goes to, be offering quite a complex scenario. At first, it seems pretty straightforward to do your masking, but when you're talking about complex applications and large copies of data, then things start to slow down and get more difficult. And that's when you want a solution that can cater for and simplify that complexity. So finally, we come to another feature or thing that I've encountered when masking databases or changing the data to fictitious values. You need to be able to perform the masking as quickly as possible. Just working with one of my first customers I worked with, actually 10 years ago when we started this, we made them a virtualization customer initially. They built a new platform. It was running on Exadata. It was 0 terabytes when we started. I think it got to 1.4 petabytes. It's now down, with a bit of archiving, down to about 750, 800 terabytes. And they've now embarked on a process of masking that database. And we are talking 250 billion rows worth of data. So you need to try and perform that masking as quickly as possible. We actually have this thing called hyperscale masking. So we can actually break that single tables up into multiple parts and then spawn multiple masking engines to try and mask as quickly as possible. So you need to look at that. If you're masking more than tens of millions of rows, then that's going to take quite a significant amount of time. You want to look at how you can parallelize that process. The value of the data cloning that I mentioned, the block sharing, comes into play there, in that you only really want to mask the database once. And also the fact that we can replicate that data using that cloning technology incrementally also helps you to distribute that masked data. And obviously, the other thing you need is the ability to mask SaaS applications, right? Or the ability to deploy in the cloud. So the Delphix solution is available in the Azure Data Factory as a SaaS solution, but also you can use on-prem algorithms and share those into that SaaS solution as well. And that final point is really about the security of your masking solution. And that last point, separation of duties, is really important. I've seen a lot of businesses out there kind of using their ETL tool or their ELT, extract, load, and transform, or extract, transform, and load. So their pipeline tool and using that to do their masking. Well, really, you don't want too many people involved in your masking process, and it really should be quite separate from your day-to-day data manipulation tooling, I would suggest. And so important to have that separation of duties, important to make sure that your whatever algorithms you're using, and if they have mapping tables, those tables need to be encrypted, the keys need to be safe, there needs to be no access to those. Okay, and that's why sometimes it's quite important to use a built solution that is quite mature and has gone through the process of hardening and making sure that mapping tables aren't available to everyone, keys and seeds that are used for some of those format preserving algorithms are not available, they're safely protected. But then also ensuring that you have access controls restricted, preferably using LDAP or whatever AV group technology, so that you're restricted and your masking tooling is secure and only available to certain privileged people. So that's it really. Some ideas and things that I've seen around masking worth considering. We can share these slides so that OUG will make these slides available to you. But that really summarizes the things that I've seen and the things that you ought to consider, whether you're building a masking solution yourselves or looking at the market to see what's available to help you with the process of obfuscating data. And if you look at this tool, I'm just going to go into a little bit of a pitch for the Delphix continuous compliance solution. The thing that I really like about this solution is that not the fact that you've got some out of the box algorithms that are ready to use for credit cards and things like that, but it's actually the customizable algorithms that have been developed in this no code graphical framework. So we used to have about 9 of these frameworks. We now have I think up to 22 frameworks, and they're all really, really useful, and they're really designed to, as I say, simplify that complexity. And what's important about algorithms, so when you create a masking job with our solution, you can do a pre-masking script and you can run a post-masking script. And that's all well and good, but that script is specific usually to the data source. So ideally, you want to get all of your algorithm components within the actual algorithm itself. So that component is heterogeneous, if you like. It works, or ubiquitous. It works whatever data you're looking at, whether that data is in an XML file, in an Oracle database, or in a Databricks store, or wherever. Okay, so the algorithm should work whatever the source of data that you're masking. So that's important. This no-code framework is also important because really, often the DBAs don't really know the context of the data, and so it's better to have business level people or security people understanding them and have them easily create these customized algorithms. So for instance, in the top frame there where it says secure lookup algorithm, that is created simply by using a list of values. So I could download a list of South African baby names, for instance, upload that list, and all of a sudden I've got a secure lookup algorithm that works. And within about 2 minutes, I'm creating fictitious values. The secure lookup algorithm also introduces collisions. So, 2 different values may mask to 1 single value. That means you can't use it to maintain uniqueness. You can't use it on a key field, but it does provide an extra level of security around the data. And those other algorithms, there's a really nice algorithm that you can't see here, but it's the regex, regular expression decompose algorithm. So the nice thing about these algorithms is that you can compose them and extend them, right? So I can use a regex decompression algorithm, and what it will do, you can take the constituents of a field and mask them in different ways. So you can build a regular expression with multiple capturing groups, and each one of those capturing groups can be masked with a different algorithm. And that's how you might say one of them's a date of birth, and you'd want to mask a date of birth in the same way as you mask a date of birth field if that date of birth is contained within a combined number value, if you like. And finally, this algorithm builder framework, if you can't do what you need to do in this simplified graphical framework, then we also offer an algorithm builder, which is based on the Java syntax. And again, that will extend and compose any of the existing algorithms, or you can create your own algorithms. And that allows you to mask in any way that you like. And that's really what gives you the ability to maintain the utility and ensure that the validation rules will still work on your masked fictitious data. Oops, I've gone the wrong way. And finally, we're not sitting still. I think the next release of our product will bring out some AI capabilities. One of the things, when creating that secure lookup list, I mentioned downloading a list of baby names from the internet, but we're bringing in AI tooling, which is you don't have to use it. It's selectable, so you can choose to use AI or not use AI. It uses language models that are maintained within the solution itself, so it's not reaching out to the internet. But within that context, then we are starting to use AI to help you with the discovery process and help you with creating these fictitious lists of values that get used in the secure lookup, the mapping algorithm, etc. And there's other things that we're working on there, being able to customize your data sets based on regional and vertical industries. Just tooling really that, again, help to simplify and speed the masking process. Because what you don't want to do, you want to be able to mask your database and still do all of the development and testing that you're doing today. You want to focus on your business and the capabilities that you're creating. And I've seen with some tools that don't offer this simplifying capability, you tend to spend all of your time working on and doing the masking, rather than the masking being once and done, reusable, resettable environment that then allows you to get on with your day job of running the business. So that's all from me. We've got an IDC report on our products that tell you about the value of implementing that block sharing capability I spoke of, and also how we can help reduce POPI data leakage risks and also improve resilience. And again, I'll send you these slides, and you can take a look at that link if you're interested. And that's all from me. We've got a couple of minutes left. There's 7 minutes till the top of the hour. So I'm going to leave it there and invite you to ask any questions. Muzi, have you seen any questions or anything out there on the chat?
Yeah. Yeah. First of all, Gary, thank you for an excellent presentation, as expected. Very practical with all real life scenarios. Yeah, it makes it very much a practical solution to go for. Yes, we've got one question from Tando, and his question is: what are some challenges to data masking?
Oh, there's always challenges to data masking. I think the main one is getting hold of the data, right? And then the other one is nobody wants you to see the data, right? Everyone wants you to mask the data, but the data is sensitive. So it's quite funny where, if you're working remotely, it becomes a little bit difficult because people want to test the masking solution on already masked data or fictitious data. And obviously masking data that's already masked is quite a challenge, particularly if you masked it with a not very good solution or not very good script. So that's one of them. I think the other one is dirty data, right? So I was working, it's okay when you've got, up to 1 million records, but when you've got multi-millions of records, tens of millions of records, there's always something in there that doesn't work. And I was working, it was actually that insurance company in Cape Town, and they had a record which said it was I think it was the SAID number or something like that. But actually, what if you're not South African, right? And people had thrown passport numbers in there, but they weren't just, all the passport numbers were different. So we solved that problem. But then the next thing, someone had just thrown random characters in there. So it was an address in there or something. And we got over that problem. And the next problem was some of the characters were non-printable. So you see what I mean? So that data cleansing is always quite interesting. And the business always says our data's clean. There's no dirty data in there. But trust me, there's always dirty data. And it's those relationships that are important. Okay. Yeah, I was working on a customer with, they operate across 22 different countries, and their employees operate over all of those countries, and therefore the employees have ID numbers. So that's 22 different styles of ID number. You might have a driving license, you might not have a health insurance number, you might have a national ID number, and they all need to be masked in a specific way, and they all need to pass validation. But there's always rules around that, right? So some people want the checksum to work. Some people don't want the checksum to work. So if you're masking a credit card, if you look at our credit card algorithm, it's quite nice. You can choose whether to mask all of the number or some of the number. So you can keep the first 4 digits or the first 6 digits, because that relates to, the credit card issuer and where that card is issued from. But then do you provide the LUN check at the end or not? And some customers want it and some customers don't. And that's why, writing scripts to do masking becomes very, very challenging across all of your multiple applications, because they may all have slightly different validation, slightly different rules. And that's why it's a nettle that hasn't been grasped, so to speak. But you need a tool that has this utility that will help you get the job done as quickly as possible. Hope that answers the question, Tanda. Tando's got his hand up again. Tando, go ahead.
Yeah.
So would you say that automation can maybe help in data masking to some of the challenges?
Absolutely. Absolutely. I mean, you've got to try and automate as much as you possibly can. In the first instance, to get through it, the initial masking challenge, you need to start to understand the data, and you need humans involved in a lot of that. But you can automate it as well. We have this set of classifiers that help to classify the data. And so, someone once said to me, look, that's okay. I can do that classification manually, or I can create a profile manually, but I have 1,000 databases, right? And so, once you scale up like that, you really have to try and automate as much as you can.
Yeah. Now, thanks, colleagues, and thanks, Tando, for those questions. We hope that your questions have been answered and have been cleared. Yeah, just as a reminder, guys, if you want to learn more about this, there's Gary's contact details. And for some of the colleagues who have maybe missed this presentation, we'll post it on our YouTube channel. And just one last thing, guys, just a reminder of our conference. On the 9th to 11th of November, registration is open. Don't miss out. Gary will be there. You'll get an in-depth discussion on Delphix tools and products that some of us have experience on and have benefited from. And I'm sure you colleagues as well may benefit from. So thank you very much for availing yourself this late hour. And we really appreciate Gary's time as well on presenting this part of the SIG. Thank you,
Gary.
Colleagues.
Thank you. Thank you, Deputy Watika. Appreciate it.
Cheers all. Thanks a lot. Thanks.
Thank you, guys. Yes, bye.
Bye now.
Good night.